So David Lee,
Yes.
put more memory in my computer and it made an amazing difference. This is the electronically assisted astronomy.
Yeah, I was wondering whether, like 4 gig is not very much for a Win 10.
No. So it looks like I'm going to be able to do it.
That's enough for the OS.
Yeah, right. Just so for those listening, I'm trying electronically assisted astronomy with my Nikon camera and my Celestron 8. It looks like it's actually going to work.
Excellent.
That's good.
Yeah, I was wondering about that because I think the Nikon controls always kind of lag behind. They do them for Canon almost kind of first, and Nikon's a bit of an afterthought.
Yeah, but you know the software that Canon writes for their cameras for talking to the camera, the Canon software itself is crap. I can't get my Mark IV to talk to the computer at all, hardly. Certainly not the iPad.
Have you tried Backyard Canon?
No, I'm gonna. Yeah, we're in the process of doing a swap on our main computers, and I just haven't got around to taking all my stuff and putting it on the new machine. When I do, then I'll be able to figure out what's going on with it. But the app that they write for the iPad is just a piece of poo. Because I was hoping to use my Mark IV on a little tripod to take pictures of my fly tying when I'm tying flies for the guys. End up having to use the camera in the iPad. When I'm talking about tying flies, this is where I sit normally on Saturday mornings. And that's the kind of stuff that we're talking about, making those little guys.
Looks like a chironomid.
No, it's actually a stonefly imitation, made with burlap. That's my project for Wednesday night, is to demonstrate that to the guys at the Hague Brown Fly Fishers.
Good for you.
I've been doing once a month with the Hague Brown guys, and I've been doing every Saturday for the guys with the golden rods and reels. So we've for the last year I've probably demonstrated 120 flies.
Huh.
Yeah, it's been great. I get 18 to 20 guys every Saturday morning.
Wow.
Fun. Keeps me entertained.
How do you come up with new material?
We try to tie flies that are in keeping with the season or what the fish are trying to eat during that course of the season. And in addition to just demonstrating flies, it's a little bit of instruction. We got a bunch of relatively new tires. So I've been working a fair bit over the last year on teaching them technique. I've spent 40 years tying flies, and I've taken some instruction from some of the most famous guys in the business at one point or another, you know, a guy here and a guy there. And I've got a lot of skills that I'm trying to pass on that I've learned over that length of time.
That's good, and that's fun along the way.
Yeah, it is. It's a lot of fun. Like I said, something to look forward to every Saturday morning.
Yeah.
It takes me, I have to spend a few hours ahead of time preparing for the session. And I got a friend of mine who you guys will eventually meet, because he's interested in astronomy, and he's going to move down. He has a house here. He lives in it, and his name's Florence Sabeck. And he's bought a house in Royal Oak, and he's going to be down here when he retires. So, but he's a good fishing buddy from Edmonton, and he and I are sort of sharing tying duties on Saturday mornings. So we get two guys from Edmonton, one from Red Deer, one from Nanaimo, and one guy from Pennsylvania that show up every Saturday morning. Zoom is crazy.
Saturday morning, shouldn't you be out up to your waist in ice cold water? That's where my that's where my son is. They got steelhead last weekend.
Yeah, where Crouchin?
Cowichan.
Yeah. It's been slow. The river's been slow, apparently.
Oh, it was a pretty good sized fish.
Yeah,
The one that I saw.
Yeah.
Probably 50 centimeters.
yeah,
It was big.
yeah.
He was soaked though. It was raining.
Oh, yeah. One of the guys from the club was up there earlier in the week, and he spent the whole day and didn't even get a sniff of a fish.
Bill, was that the day that it was snowing and sleeting up there?
Yeah.
It was yesterday.
Oh,
Yes.
He was in rain gear and he looked really wet.
Well, right now, if you're gonna fish,
And there
the
was
river's-
snow at our place this morning.
yeah.
Wow.
The grass was snow.
but the only thing,
I've turned on video recording just in case anyone cares.
yeah, about the only thing you're gonna fish right now is outside of the couch, and is maybe beach fishing for some sea run cutthroat. The lakes are all too cold. The fish are just lying on the bottom.
The moon is out for those who are interested.
Yep.
Well, good evening, everyone. I think it's probably should get started as it's about 5 minutes into our new time. Welcome everybody to Victoria Centre Astro Cafe this evening. Good to see so many people here, despite the earlier hour of this meeting. And it's funny to look outside and see it's a bit light outside still, and only going to get lighter as the season moves on. So far this evening, I have Ken had asked or has something to show us, Randy and Reg. Has anybody else got something they'd like to share this evening? Hearing none, I guess we could, Ken, are you ready?
Yes, can you hear me?
Yes, we can.
Oh, good. So I haven't used the tablet for Zooming this way, so if you don't see anything, you'll have to tell me. All right, so do you initiate sharing or do I?
You do. So
Right.
you should have a share icon there, share screen.
I should hope so, somewhere.
Hopefully.
Yeah. Yeah.
Is it an iPad?
It's a Samsung tablet. It's a fairly new one, but
Tap on the upper top and then the thing should show up on the top of the screen. And then it should drop down. It'll be green.
okay, top left, you thought.
Well, I tap anywhere that I tap on up at the almost the very top of the screen. Then I get a drop down that has all my icons on it.
All right. So I have,
That's an iPad.
that's an
But I
iPad.
imagine- But I imagine the other would show.
Well, they should be, but
Does anybody know where it is on an Android app? Looks like Jim is having a look.
I tried it out yesterday with a friend and it does eventually work.
Yeah. And unfortunately, they seem to put these things in different locations and different versions of this lovely software, so it's hard to tell people exactly where it is.
Yeah. Okay. Back to meeting. Oh, all right. I got out of the meeting somehow.
Did he disappear?
Looks like we've lost him.
Yeah, did we? Yeah. Okay.
Chris, the other option is maybe he can send you the presentation you could present, he can just speak.
Yeah, if you can get it to me. Yeah, see if he's back yet. Or what we could do is try and see if we can figure this out in the interim.
He's coming in
And
now.
yeah, he's back. And
Yes.
I see Jim's got a second presence on here, so hopefully we'll have some luck with, because I think he's got an Android.
Ken, if you can't get this working, maybe send your presentation to Chris.
Lose him again?
I can do that. It's basically
Okay.
a PDF file. You can read a PDF file as well as I can read through it. So
Yeah.
that might save a lot of time.
Yeah.
Eh?
On my Android device, right at the bottom of the screen, you just touch the screen anywhere, and the menu comes up right at the bottom in the middle. There should be a green icon.
Yes, I see. Share. Yeah. Okay.
So let's try that and see if that will work.
All right.
So it's reverse of an apple.
If I can get.
Hey, there. Oh, we're getting something. Yeah, I think we're getting it.
Yeah. Okay. So actually, that was an effort I put together for last week because that was International Women's Day. Naturally, there was a glitch and it failed to load on my tablet. Anyway, so here we are. Basically, a brief talk about 4 women and 1 man. Vera Rubin, everybody has heard of, famous for essentially giving us a heads up for what we now interpret as dark matter because of the unusual rotation properties of galaxies. One thing I found is that the American Institute of Physics has a very handy website where you can get oral histories. And the oral histories come in 2 flavors. One is essentially transcripts. And this first URL at the top is a directory to transcripts. And you can type in somebody's name or go through the alphabetic list there. So Vera Rubin, for example, is one of their transcribed records. There's also, okay. There's also oral history, meaning audio recordings, and not nearly as many, but there are some. And for this one, I typed in Plaskett of all things and led to another woman, which I hadn't expected, Helen Hogg. She was quite well known in Canada, a few decades ago. She was at the University of Toronto, and apparently she knew Harry Plaskett, who was the son of John Plaskett, who did the observatory in Saanich. I take it back, she may have known John Plaskett, yeah, or both of them. Anyway, so there's an interview there with Helen Hogg, should you care to look at it. So the next person I think I talked about some time ago was Emmy Noether. Got to use the German pronunciation, Noether, as in Goethe. She was sort of a tragic case, absolutely brilliant, I think, to the level of a Nobel Prize. And she was a mathematician, but her main discovery, I believe, was that she showed mathematically that if you have a symmetry, that leads to a conservation law. Well, what's a symmetry? For example, if you believe that the laws of physics are the same in Victoria as in Vancouver, that's a translational symmetry. And strangely enough, that leads to the conservation of energy. And her theorem explains that. So if you are brave and have intense mathematical skills, you can find, descriptions of how she derived her theorem. There's one reference at the bottom. An interesting book called, there's a series of 4 or 5, The Theoretical Minimum, basically initiated by Leonard Susskind, who was a good physicist. And one of his books is on classical mechanics. So the third person, again, most people will have heard of, is Augusta Ada King, apparently the daughter of Lord Byron. She worked with Charles Babbage, who put together a plan for a general purpose computer, entirely mechanical, and devised an algorithm which would have worked on that machine if the machine would have worked. So she is said to be the first computer programmer. If you're in London, one of the museums, I think the British Museum, has the analytical engine. And I can't remember if it's as it was left by Babbage or if somebody went further and actually did the machining. That was where Babbage was stuck in the 1820s or 30s or 40s. Machine shops really couldn't fabricate machine parts to the quality that were required. Obviously they could now. And as I say, I'm not sure if the exhibit in the museum is the full-fledged deal or not. Anyway, it's quite an impressive big piece of hardware. The next person I've never heard of before, but strikingly interesting, a Scotswoman, Mary Somerville. And she grew up in the last era, I suppose, when a clever person can know pretty much everything about science and math. So she studied math and astronomy and was nominated to be the first female member of the Royal Astronomical Society. Same time as Caroline Herschel. One thing that surprised me is John Stuart Mill, who I vaguely knew as a philosopher, was also very involved in supporting women's liberation, if you like. He wrote a book called The Subjection of Women and organized a petition to Parliament to give women the right to vote. He used the line that, this is in the time of Queen Victoria, he said, "No, we are able to accept that women have great power," i.e. Queen Victoria, so why not, and responsibilities, so why not give them the vote? Unfortunately, his motion didn't pass. Anyway, she was well known in England, and again, I didn't know this. It was after her that Somerville College in the University of Oxford was named. One of the things that she did is she wrote a translation of Laplace's book on the mechanism of the heavens. And it was an excellent translation. You can get it for free at Google Books. That's the URL at the bottom. They don't make that URL easily available now. I think because Google got into trouble because they did this mass copying of millions of books. Basically any library that would let them in, they copied all their books, and then they got into copyright squabbles. So they still have quite a few free to download books, but they're just not pushing that side of their offerings. She was much influenced by Alexander Humboldt and wrote one of her own books later on called Physical Geography, which reflected Humboldt's views. And that takes me to the last person. There's Mary Somerville. Interesting appearance. Very thoughtful and a nice person. Anyway, so Humboldt, I don't know if he was a supporter of women, probably neutral, maybe, because he was not known in his long life to have ever had a romantic engagement with a woman. But they kept falling in love with him because he was a good-looking guy. So one woman asked him, "Have you ever been in love, Mr. Humboldt?" "Yes," he said, "deeply in love, with all my heart. I'm in love with science." And so, well, why not? Each to his own. But one of the many things I found astonishing about him is his energy just went everywhere. For a time, the Kaiser of Prussia, because Germany was not united at that point, gave him a big allowance, said, use it wherever you like, go wherever you please, because already Humboldt was known as really brilliant. So give him a free hand and see what happens. So for a couple of decades, he traveled the world. I mean, this is an era when you travel by sailboat or by horse or by Shanks mare. He went to much of South America, east as far as Russia, Siberia rather, and then eventually came back to Europe. And at some point, the Kaiser said, okay, you've had enough fun. I want you back in Berlin. So forcibly, he came back to Berlin, and he decided, this is boring. Berlin's boring. So he decided, well, I'm going to give some lectures, put some juice into the place. And so he gave lectures, and they were so popular that he added more lectures, put them on in music hall, the Zing Academy, and for 6 months delivered lectures several days a week. Hundreds attended each talk, and he didn't charge an entry fee. He democratized science. So in that sense, he was a supporter of women. His packed audiences range from the royal family to coachmen, from students to servants, from scholars to bricklayers, and half of those attending were women. So it caused such chaos that the police had to be called out to keep things under control. So anyway, interesting story. So there it is. That's it for me.
Great, thanks, Ken. Any questions?
There's a Canadian connection with Humboldt. He recognized early on that the geomagnetic field needed to be monitored all over the world. He was the first one to promote a global network of magnetometers. And
That's right. Yes.
so he contacted the Royal Society in London because of the British Empire and their presence all over the world.
Mhm.
And it was, somewhere around 1820 that they opened the observatory in Toronto. And it had a continuous presence until the streetcars made it impossible, and then it moved to outside Ottawa. But that was one of, I think, it was about 8 or 12 magnetometers that made recordings all over the world.
Yeah, I read that he would personally carry a magnetometer up some, damn high mountain in South America just to establish, the magnetic fields or whatever. Yeah, and it was heavy lugging. He really did physically demanding adventures.
Yes, you can. Actually, in South America also, he climbed most of the highest volcanoes in Chile and some of the others with two different kinds of altimeters that were in vogue then, trying to determine the heights of those mountains. And he had to establish the stations going down to sea level, and they were all instructed to take the measurements on a certain day at a certain time, and all the hassles of carrying these delicate glass instruments up to a volcano through. It was amazing. And he's also, as a biologist, he made many contributions as well. He's really an amazing scientist.
Yeah, he did everything.
Yeah.
It's one of my pet interests is the shape of progress over time, and one way to measure it is to get scientific books from some era and then compare it to the next era, and then so on and so on, and you see this huge expansion over time, which always makes me think whatever we think we know now, it's basically a pittance compared to what we will know in the next era. I started on that because you can get Humboldt's books. He wrote extensively, and they're all free on Google Books and elsewhere. And so you can get a picture of the scientific view of the world a couple of hundred years ago. It's quite amazing.
On that note, Ken, could you go back to the screen slide with the that link on it? Because Lori asked if you could post it in the chat, or could you display it for us? So the Google Books link.
Oh yeah, because that's, there it is. Yeah, I can send this file to Joe if that helps, or he's got his recording going, whatever. Here, does that help with the URL?
Let's see if that's there it is. Yeah.
Yeah, just send me the PDF and I'll put it on the website.
Okay. Yeah.
Thank you.
You're welcome.
That seems to work too. So just put something in the chat as well.
Oh,
Thanks very much, Ken.
Yeah.
You're welcome. Oh, one last thing. We have a Humboldt Street in Victoria. I suspect it's named after Humboldt. And there's Humboldt, Saskatchewan, but maybe not Humboldt, Alberta. What's with Alberta? I'm sorry, guys.
Great. Okay, can you see how to end sharing there?
I stop share, yes.
Yeah,
Okay.
there it is.
Done. Sorry.
Great. Well, thank you again. That was interesting. Any further discussion about that, or shall we move on to Randy?
Good.
Okay, Randy, you're up.
So one of the things that came up on my feed this week was this image of the day from NASA, and it just immediately attracted me. It's not a recent picture. It was done in 2012 by an astronaut on the space station, Don Petty. But it's got so many things in it. So let's just describe it. So this is through the cupola of the space station, and that's not around Polaris. That is seeing star trails around the arbitrary axis of the space station. They made it so that the space station is always pointing down at Earth. So it's spinning around just like the moon, so that it takes one rotation every 90 minutes, just like the space station takes 90 minutes to go around the Earth. And usually, they're interested in taking nice sharp pictures of the Earth. And so they have to kind of pan their camera to get the really good pictures on the Earth, or do a very fast exposure. And what this astronaut did is the absolute opposite. He would take, I think he said there were 30-second exposures, and then would pack them together. And so you can actually see that with the lights on the surface of the Earth, you can see these bars, and those are just that little bit of gap between each 30-second exposure. And so I downloaded the picture, and you can blow it up, and you can see in some of the brighter star trails, you can see those breaks also. Of course, if we had Diane here, she would be able to look at the ends of these and say, oh yeah, I can see what constellation that is. But I don't know anybody else. But take a look at this guy. Do you see that? Can't imagine what it is. Any ideas? That's a hell of a bright light moving perpendicular to the stars.
I would say it's a rocket.
You would think. There's another one though, and I mean, there are lots of things.
Or satellite.
Yeah, I guess it must be a perpendicular satellite that just in a different orbit, and it caught the sun just right.
And it would suggest it's moving quite quickly if those are the gaps between the photographs. They're much longer for this. And the exposure, the 30-second bit seems shorter. So that's quite interesting.
Oh, that's right. That's right. How do you explain that?
I don't know.
Oh, got to think about that one. And then this green glow, that what makes green in the atmosphere when it glows? Is that the nitrogen? Wouldn't surprise me. There's more nitrogen than anything else. And then we have lightning as it moves along. I mean, there's just so much in this picture. I just love it. And that looks like during that time, this part of the station was moving around, whereas this part was stationary. Anyway, you know, this is one of those rabbit holes that one goes down. So when you Google ISS star trails Don Petty, then you get to this Flickr site, and he did some fantastic versions. So there it is. You know, you can do this with star trails too. If you're at the equator, then they all look like they're going up and down. But look at these pictures going through the cupola. So this is the land, and there we see the stars going around it. Tell me if you want me to stop anywhere, but I'm just so blown away. In one of the descriptions, it said you can tell the difference between fires and city lights because the fires kind of flicker. I haven't seen that. Ooh, I wonder what that guy is.
Moon.
Anyway.
Good find, Randy.
Most remarkable thing that I've ever seen from the videos from the ISS are the lightning flashes. That,
oh yeah, aren't they beautiful?
It's astounding to watch. And something that I just read about a little while ago is they've actually managed to catch the sprites and jets that will appear over top of the lightning strokes. They're just millisecond long flashes that either blue or red flashes that are associated with jets of electrons or gamma rays coming up from high energy lightning flashes.
Wow.
Fascinating pictures, Randy.
So these lightning strikes, they're used in geophysics because they are constant. All around the world, there are electromagnetic waves that are mostly formed from the tropics, but we see them up here, and they're used to actually as a big energy source to probe deep into the Earth's crust using what's called magnetotellurics. So I'm not surprised that there are these constant lightning strikes as they fly around the Earth, because I just know that the magnetic interactions are seen all over the globe. Okay, so that's what I wanted to show first. Chris, should I move on to the sky this week?
Sure, that would be great. And thanks for sharing that. That's fascinating.
Yeah, again, I don't know why they decided to put that on their image of the day last week, but it certainly caught me. So this is the Sky News this week's sky, and it's not a particularly exciting week, but this is pretty classy. Tomorrow night, you should be able to use the moon to help you find Uranus, which is a rare find. It's within 3.5 degrees, so within a binocular view. I don't know, has anybody been able to see Uranus with binoculars? Or is it more a telescopic target?
Well, part of it's trying to figure out what you're looking at, but yes. Yeah.
Well, what they said is it's nice having the moon to help guide you, yeah. But usually the moon is too bright. Yeah. But being such a thin crescent, it should be helpful. So that's tomorrow night. And then by Friday, then the moon will overtake Mars. And I did get to see Mars and half of the Pleiades within my binoculars last, when was it? Lovely clear night last week. Was it Thursday? Wednesday? Anyway, so you can see how far Mars is moving along, but they'll be pretty close together in Taurus. And that is always a pleasant view to see two objects in the same view. 3 degrees apart in our evening. And then the thing I really thought was worth talking about is the vernal equinox. Because while it is really of no astronomical importance, it's extremely important because we use that as our zero for the longitude. It's the celestial meridian. Just like on Earth, the longitude is completely arbitrary. It happens that 0 degrees east or west goes through the middle of Aries transit telescope in Greenwich. At some point, they decided to use the 0 for the celestial coordinate system to be where the ecliptic, so the path that the sun travels on, where it crosses the extension of the equator. And it's nicely defined, but there's a problem with it. And that is that the Earth wobbles. It goes about 1 degree every 72 years, which turns out to be, it goes around the whole 360 degrees in, I don't know, 20 something thousand years. And so that is why you see things like Epic J2000. So that's Julian day, and the time is, noon at Greenwich in the year 2000, and they use that as the epic. So when you see epic on a star map, every 72 years is going to be 1 degree out, and there's all these corrections that have to be made. And so since I don't know that that's important. Is it important when it comes to dialing in your go-to telescope? Down in Arizona, are your telescopes accurate enough that you have to worry about the epic? Garry?
I honestly don't know, I'm embarrassed to say.
Yeah, a degree is a huge space in the sky.
Well, that's over 72 years. Garry hasn't had his telescope that long.
No, all I know is that I do a one of those, we align it with about 300 stars and it works slick as a whistle. So
Okay.
That's why I'm not a real astronomer. I'm a button pusher astronomer.
Okay, but Garry, that's the trick.
Yeah.
You're using probably Epic 2000 because that's the most common, but it's calibrated because you're actually pointing at those stars, and so it doesn't really care. That's right. Anyway, what's happened since the Hipparcos spaceship did that collection of, I don't know, what was it, 1 million star positions, and now Gaia with its billion star positions, they have set a new coordinate system based on the positions of quasars, which are far enough away that they just have no proper motion. And so forevermore, astrometry will be based on something which is equivalent, but much more precise as the Epic 2000. So every 72 years, you don't have to move a degree anymore because they will be fixed to what's now called the, the International Celestial Reference Frame or something like that. I should get these words right. But this is important when you're talking about these high precision sort of work. So what was done using Earth-based astrometry and was good enough now is just not nearly good enough when you're trying to find the parallaxes of stars that are on the, in the Magellanic clouds and things.
Randy?
Yes.
Just as to the best of my knowledge, and I could easily be wrong here, as I understood it, the epoch changes were to essentially calibrate a system that was based on an Earth-centric system. It was based on Earth references, and because the Earth was a shifting reference, they had to change the epoch value every.
There's several. You're opening up a whole can of worms. So you've got the geocentric system, you have this barycentric system, so the center of mass for the Earth-Moon system. You have the solar, the barycenter of the solar system, which is essentially what they're doing with Gaia. But it doesn't really matter because they're using the quasars, which are so far away, it doesn't matter what the center is anymore. But
there's a chapter in the RASC handbook, I think it's the chapter on time standards, and they get into that whole system as to whether you're dealing with the geocentric system or the various mass centers anyway, and then it gets really interesting because for the Jupiter missions, they wind up having to at some point shift over from the barycenter of the solar system to the barycenter of the Jupiter system. So,
right, that would be there'd be a point. They say it's no longer useful. We're not in transit anymore. We're in this new reference system, and they have to actually click a switch to change their orbital dynamics calculator. That's right.
I was quite entertained by the chapter, but when I tried to read it aloud to my wife, she wasn't as entertained as I was.
Well, different strokes. But no, the epoch, there's two different things. There's epoch and there's equinox. And so oh dear, I just read about this afternoon. If you're trying to correct for the precession, you would still use the epoch. So you'd use J2000, for example, but then you would use your current equinox to make that little bit of correction for the precession over the last 21 years. But you need to use epoch if you're looking at proper motion. So if you're actually looking at how the stars are moving, then you would be dealing with epoch. And they say with Gaia, data release 1 was epoch 2020, and data release 2 was epoch 2020.5, because it was halfway from the beginning to the end of the mission so far. And so when 1 year had passed, they had to add half a year, because they wanted to say, where are the stars in the middle of the time span that they've been moving during the Gaia mission? I'm just blown away at the sort of precision that they're having to work with. There's one more thing that is in the news this week, also on the 20th, but I think a bit early for Victoria. It looks like it will take place at 6:30 p.m. Saturday. Finishes, when does it say it finishes? But a few hours later is the Lunar X, which is where the light just catches the top of a couple of craters and makes this pretty X. And it's right after the quarter moon. It's one of those lovely things that when you see it, you say, yes, there it is. How many people have seen the X and the V?
Seen
Several
both, and I've
times.
photographed the X a couple times.
So that is Randy's rabbit hole this week.
Thank you.
And if people are into asteroids, Vesta, one of the brightest ones, it's easily findable right now.
Why is it easier now? Is it that it's close
Well,
by?
it's at opposition, so it's at its brightest. I caught it, glimpses of it naked eye on Friday night out at Pearson. And then it was easy to pick up with binoculars. But the triangle of the tail of Leo on the west side, in between the upper and lower star of the triangle of the tail, just to the west of it, if you put binoculars on that space, you'll see 3 stars, but one of them is Vesta. And so on Friday night, it was like a little check mark where Vesta was the easternmost, and now it's above, or last night I could see it with binoculars, and that was with like 10 by 40s. It was still easy standout. It was just above the star it was next to, and now I guess it will be actually probably, if you have stellarium or something like that, it'll show it. And it's easy to mark the progression right now as it's moving past these 2 other stars that are the only other bright stars in that space. But it's brightest of the 3 in that spot. So that's why when I could just pick it out on Friday night, I knew it was it, because the other ones were too faint to be seeing naked eye. And Stellarium said it was 6.1 magnitude.
You can see 6.1 up there. That's great.
Yeah, it wasn't a very good night either.
Can I share the screen for a moment, Chris?
Say again?
Can I share the screen for a moment?
Sure, please do.
There we go. There's just a quick view of my carte ciel. You can see Vesta right in there in the tail of Leo. That one.
Can you enlarge it?
There you go.
Oh, it doesn't show the other stars.
There.
There they are.
Yeah.
See, so it was to the bottom left of the lower one. So it's right in between the 2 now. Because that yellow thing is a galaxy.
There we go. I had that up, and I just thought that would be easy to show.
Thank you so much.
If you can see those 2 tail stars, you could pick it out with binoculars from the city.
Great. Yeah, very neat. On that note, did anybody try the visiting the Mount Lemmon Messier event?
No.
No. Okay. Just wondered how if anybody had gone and or tried it out to see what was happening. Great. Okay, I think Reg, you wanted to share some things this evening, or a thing this evening.
Well, hello, rascals. First of all, a question for Randy. I didn't quite understand what you meant when lightning discharges were hitting the Earth, and you geophysicists were using them as some sort of way to measure some magnetic properties. Is that it?
Yeah, there's essentially, once you get away from the near field, then they're just these plain electromagnetic waves, and it has a whole frequency spectrum, but it's in the 1 to 100 hertz is where most of the energy is, and so that is a very good way to get electromagnetic energy into the Earth, which you then monitor, and you can see how conductive different layers are below your feet. So you set up electrodes and you set up magnetometers, and record for a couple of days, and measures the conductivity as a function of depth below your feet. And you set up this equipment all over the place, and you can find the structure of the Earth underneath.
Fascinating.
And then for lower frequency, it's actually the magnetosphere, which has waves. And so you can get lots of energy even at days and weeks. And so that's for probing very, very deep in the Earth's crust. You can go down hundreds and even 1,000 kilometers and see what the conductivity structure is. But that's using magnetospheric deformations.
Wow. Well, thanks for that. I'm going to try and share the screen if that's okay, Chris.
Please do.
Uh-oh. We are. Okay, what I'm going to do here is get rid of all the people. And I'm going to put it into slideshow mode. And we'll start this. So basically, on February 22nd, Perseverance landed with great fanfare. And I don't know if many people have been following the progress since. I know we did not make any mention of it at last Astro Cafe, but they actually flashed up the motor and moved Perseverance on March 4th. So I just thought I would check into it, and I kind of got sidetracked, which often happens. But this is a kind of a full panoramic view of the system, and it's quite a complicated image to take this thing. They have an explanation for it on one of the NASA websites, but I didn't have time to go into that. But it shows rather spectacular fashion what the you can see the spacecraft as well as the horizon and some bumps up here, which we get into, including little thing there. So what I'll do is show you this. This is the first tracks, I guess. It landed here, and then it drove off. And it seems to me like the first thing they did was it did a donut on the Mars. So that's kind of interesting. At any rate, so that's about as much as I'm going to talk about that, because and there's a nice panoramic view of some portion of the screen, but it's kind of meaningless unless you know what setting you've got there. So what I did was I went and found out where the Perseverance was going to be positioned. In contrast, the other active rover right now, Curiosity, was over here on the Martian surface. And it's interesting, if you look at that, we're fairly close to the equator area around here. But if you look at John McDonnell's picture, the Perseverance landed in this area here on one of John's beautiful Martian pictures that he took in September. So there you go. So what this is called is Jezero crater, or Jezero crater. I'm not sure how you pronounce it, but I know J is spelled pronounced as a Y because it comes from I think the Baltic states. That's how the Baltic nations pronounce things in that manner. So it's this crater is positioned right adjacent to a large basin, and there's higher ground in this area here. So why did they do that? well, if you look at this as Jezero crater, you can see two channels, a meandering stream coming into it and another stream exiting the crater, which indicates that at one time this must have been kind of a lake bottom. And as the debris sediments that are in the liquid as it flows into the lake here, it would all slow down, and it would deposit the sediments because there's not as much kinetic energy to keep them suspended, and they would pile up and form a delta here. So that's why they wanted to place the Perseverance very close to this delta, because they thought that it might be an ideal place to explore to see if there was any life forms in that area. So it looks pretty nice. And then somebody did an artist's impression of it. And this is what it would be like. It looks quite beautiful, actually. The water flowing in through here and then exiting down this way. So it was kind of a neat thing. So at any rate, then in gory detail, they've got all the details for the delta here, plus a couple of bumps around. And this is the position of the Perseverance lander where it landed. So what I'll do here is just go ahead, and they named this after a science fiction author, and I think we mentioned that was mentioned in a previous Astro Cafe talk. But if you look at it, the scale here, that's 1 kilometer. So I just wanted to draw your attention to this mound here. And this is the edge of the delta in this area here. Plus this is also kind of a remnant as well, where I think that they dropped a lot of the sediment there. So pretty interesting area. And I think some of this area in here is kind of tricky for a rover to traverse. So they're going to go around this area here. So they've got a couple of proposed tracks that they're thinking of taking it on. And one is that the rover would be here and it would swing around this way and go up kind of a valley to explore the delta, and then come down, and you can see one of the streams coming down like this. Whoops, I just spoiled my shot there. And then they're going to carry on up here, and this is the main valley that the debris is coming in on. So it looks like a really quite an interesting journey they've got planned. The other approach that they could have is to go down this way and swing around and go right in front of this interesting looking mound there. So the next picture that I just flashed in there, this is a picture of that, and this is 2 kilometers away. And in the background, you can see the mountains of the wall of the crater. That's what we're looking at here. But what we're looking at is something that's 10 meters. So we're looking at something that's about 100 feet high or so here. And look at all the rocks around here. That, you know, I think that the artificial intelligence in the Perseverance did a terrific job selecting an area that he didn't land on a rock, because that would be that would be the end of the mission right there. So that just shows you how challenging it all was. So what I'll do next, well, that's the end of the slideshow there. So I'm just going to exit and go back in again. So I'm going to stop this, and then I'm going to share the screen, and I will try.
How long do they think they'll take to do that traverse?
Well, they've got plenty of battery power, or I guess they've got a nuclear device powering that. So I think we're talking maybe a decade or so. So it's going to be a long journey. So what I'm going to do now is try to get to this. So they had I'm a sucker for this. Let's see. What I did was I downloaded a picture. Now this is a 250 megabyte picture that shows the high resolution all the way along. It's just quite an amazing thing. So I encourage you to bring this up. That was that feature that we were talking about. You remember that the rover might come right in front of this thing, maybe study some areas around here, because this is all, you can see the sedimentary layers in this rock as you go by. Or a rock is probably a forbidden word, the deposit. But if you go along here a ways, and we're going towards the big part of the delta, you can see the top of the delta there, and pardon me, get this along here. You can have great fun exploring this yourself. You can see the level of the delta top and all of this sort of stuff. So if I go along here, at one point, I think it's here, that they've got it. They found a pathway where you could drive up and then explore the upper areas with where it would be possible for the Perseverance to take that trip. But or maybe it's here. Maybe this is the area. It's a bit lower lying area here, and you can see a bit of a break on the rim of the crater where that canyon would have caught through and delivered the water and sediment to this area. So we got to think of this area here as basically being the bottom of a lake that is long since dried out. So I encourage you to go to the NASA sites and check out this beautiful panorama that goes on in great gory detail. It only is 250 megabytes in size, so you have to be patient if you download it. It's a lot of fun to do. So that's already, I've explored the surface of the planet, and I'll stop the share there, and I'll leave it at that.
So Reg, that shot's also available in 4K if you want to have a look at it that way.
Oh my gosh, is that right, eh? Yeah. Well, I'm behind the times. So I don't have a 4K TV yet.
There's an awful lot of round rocks in that picture, which is what I noticed, boy. Let me tell you.
Is that an indication that there was water flow shaping them into boulders?
Yeah. Well, Randy, you're our geologist here.
Well, in principle,
yeah,
rounding, but it could also be, no, on Mars, there's what they call aeolian processes, which will round anything. So they're sandblasted.
Oh, sandblasted.
So I would be surprised at what's not rounded, considering they have those big dust storms.
I say, good point.
Yeah, there you go. It's done every day.
The other thing might be the age of that crater. If you found things on Earth of that age, I don't even know we would recognize them as living in any way.
Well, that's a good point as well.
There's no crust of the Earth that is 3.4 billion years old. There are minerals that you'll find in rocks that are that old. But the oldest, I think, like province or area, I think is about 3.2 billion. Now, how did they date that? Is that just by crater counts?
I just saw the note on the thing that Reg shared. It said so many.
Yeah, it's a 3.4, but there's been no actual sample return yet, so there's no absolute dating.
Well, if things go well, I think we're going to know an awful lot more about that area in 10 years from now than we do right now. So it'll be kind of an exciting thing to follow along on the exploration. If I may just share the screen, one last thing, I just wanted to point out something. And I will go back to Safari. And the last week it was mentioned that there was a photometry lecture given. I think Sid told David Lee about it, and David kindly sent me the link to it, and I listened to the photometry thing. But then I started exploring the American Variable Star Association's web, and what a rich source that is. And I hadn't really dug into it, but I came across two website presentations that I just wanted to briefly mention that are there. This one here is comparing CCDs and CMOS sensors. And Arnie Hendon was been heavily involved in this organization about variable stars, and he did a comparison. And if you looked at their earlier book, they treat with great disdain the CMOS sensors. That's all changed. He is now saying that the CMOS sensor behavior with the systems that he checked out are just as good as the CCDs, and the linearity problems are not that big of a deal now. There are disadvantages and advantages of the two different types of camera sensors, but it seems like CMOS is, you can do pretty good photometry with CMOS. And the lecture that David Lee suggested that I listen to was on how to use a digital single lens reflex camera with one-shot color to do photometry. And that was a worthwhile listening to that. So this would be for our crew that's considering looking at a potential camera for the VCO. These guys are all really gung-ho in the latest Sony 455 chip, and a number of camera manufacturers are coming out with a system that utilizes that chip. So that was one thing. The other thing that I found was a lecture by Dr. Louisa Rebel, and she gave a talk that just blew my mind. I don't think I've ever seen a presentation where I learned more in the 45 minutes than I did in that talk. And it was, believe it or not, they're able to detect the rotation rates of stars using a bunch of clever techniques. And in particular, they used the Kepler system when it was in its K2 system, and also using the new system that replaced Kepler, and they're looking at the data from that, and she's coming up with all sorts of spectacular conclusions about this, and I learned a lot of that stuff. So I would say that there's a real a wealth of information. These guys have really got their act together, and I was really impressed by this group. Perhaps you checked in there. And then there was this other lady, and she gave a talk on the things called LPVs. And I thought, what's that? Little purple Victorians? I didn't know what that was. Those are long-term variables. And those are variables that can last between, variables maybe in the neighborhood of years to months, where these variable stars fluctuate. And she was very complimentary of the amateurs that have been monitoring the brightness of certain stars, because they've shown that a periodic changes would occur where the stars would rapidly drop off in value or in magnitude, and then come up again. And what they've been able to do is that by monitoring having the amateurs monitor the intensities, they can tell when it's going to do a steep dive. And because of that, the authoritative nature of this stuff, she's been able to get time on Spitzer, on the Fermi telescope, and on the Hubble Space Telescope to take pictures of these stars in a particular thing. So the ones that she talked about were Betelgeuse and Myra and a couple of other major, or Antares. And it was just mind-blowing what they're able to do with this. The Hubble and systems like that just pick up the corona of the star to high detail. But with the other sensors, they can pick up plumes of gas and jets that are coming off these stars, and it's a totally different ball game. So I hadn't been keeping in touch with this, but it's time well spent to go check this out. So all you have to do is go to YouTube and type in AAVSO, and they come up with a whole raft of these videos. So just another black hole to explore. So I'll leave it there.
So just one comment, Reg. Last Saturday, I attended another AAVSO lecture, and it was about some astronomical research that I've been doing. And I hadn't realized that the light curves that are used for investigating these stars are not used trivially. Like I always think of them as being, oh yeah, something's eclipsing binary, and then you see the light dip, and then you can see it come back again, right? Through some kind of periodicity. But I was fascinated to find out later that some of these stars, let's say when they compress, they become like a white dwarf, that the shell puffs out, and the shell's illumination affects the light curve. And I just never thought about that. But they showed the light curve, and then they showed in the shallow of the light curve, they showed this bumpiness. And they've deduced that this bumpiness is from that shell that's sort of sprung out with great force from the star, and then it's detected through the bumpiness of the plateau in the light curve. That I found that fascinating, actually.
Yeah, I think it opens a whole new world, or a different lens at any rate. And I really would not have found out about this lecture if it wasn't for Astro Cafe. So I think it really does help us learn and broaden our knowledge. If we did everything on our own, we would not nearly be as far ahead as then compared to the sharing that goes on here.
Yeah, so I'll be kind of reporting in from time to time. The AAVSO has actually found me a mentor, and I'm actually meeting him tomorrow at noon on Zoom, and we're going to go over some of the basics of how I can get started. So I'm hoping to do it in a couple of ways. The DSLR method is actually quite easy to do, and I kind of want to learn that one. I kind of want to do them visually as well. That's a traditional way, but I also want to use my CCD. So, well, I'll find out tomorrow what I need to set up.
What do you
Exciting,
think,
David. I just say that I checked into it, and they've got a really nice starter program where they have 10 recommended stars, and they got a beautiful write-up on how to find them and do this. So,
yeah, I'm sure my mentor will do that, and I've also just started reading some classics on observing variable stars. Many of you probably know David Levy, but he wrote quite a classic book called Observing Variable Stars some time ago, at least 20 or 30 years ago. But it's still quite a good book, and it's a good summary of the different types of variables.
So, Chris, that's all I have to say.
Great. Well, thank you. Any questions for Reg or David? Nothing. Raise that.
Oh, I may as well talk about the other thing I've been doing. So Joe and I have been slewing, and I've had a lot of fun in the last couple of days picking up southern objects. So I picked up the jewel box. I've been sort of looking around the Orion area as well. They've had their fair share of weather problems. Canaries have been out, but I've been using mostly the Chilean observatory scopes, and they've been a lot of fun. The other thing I'll have to remark is that I'm so used to digital SLRs and Sony chips that I've never really had to deal with chip defects, but these telescopes use very large codec chips, the 16803, and they have lots of defects. And I've just started to learn how to get rid of the defects, because I've never had to do them before. So that's something new that I've been sort of thrown into. And yeah, it's been a lot of fun, actually. I don't know how you're making out, Joe, but
Did you find out how to get FITS files versus PNGs?
oh yeah, I know that. There's a bit of a trick to it. I'll tell you how to do it. I'll send you a note.
Sure.
Yeah, and I've been having fun doing the quests as well. Like the way Slooh is organized is they kind of make learning fun, sort of thing. Like it's kind of like an active learning kind of environment. So you have these quests where if you're interested, let's say in nebula, or you're interested in the moon, they have a bunch of exercises. So they give you a little bit of history about the topic, and then they give you examples of objects that sort of demonstrate those pieces. And then you go out and you schedule the imagery of those objects. Then you paste them into your little assignment thing, and then you're asked to write about it. So it's kind of like you learn a little bit, and then you sort of demonstrate that you understand what you were shown. So it's good. I like it.
Very neat. So be interesting to see more as that progresses.
Yeah, I would highly recommend it for the price. Don't spend 60,000. I mean, these telescopes are like 60,000 a piece, right? Between the mount and the telescope and the imagers, and like, don't invest your money in that. Just try it. Like I think it's great, and I'm hope eventually the VCO will do that as well, and of course the RASC robotic. But yeah, you don't necessarily have to buy it. I think I like this idea of leasing, especially when it costs a lot of money and you can't even do it right now. You can't get down to the southern hemisphere. So I've had a chance to sort of sample that.
Very good. Great. Are there any, on another note, well, we've got you there, David, are there any SIGs this week? I believe the makers group is Thursday.
Yeah, I'm really excited. Jim's kicking off the makers SIG. I've got a lot of unfinished projects, so I want to sort of pick everybody's brain. So yeah, I hope more people sign up for it. Jim, do you know how many people are signed up for the makers group?
I've gotten only one direct response, but I know it went out on the email, so
okay.
I think that I'm going to get a fair number that way.
Okay. Well, I'm going to be there for sure, because I've got Jim, a lot of.
Did you get mine?
Yes, I did, Brock.
Okay.
Yeah, I'm going to sign up too, Jim.
Okay.
Yeah, I hope it's a really active group, because I'm sure we can sort of help each other out. I know that even within the EAA group, we've just been throwing some ideas around, and it's great. There's certainly things that each of us have done that the others haven't. So it's a great way of sort of sharing information.
Well, even just thinking even in terms of the technology is some of the things that I think it was Randy was describing about the using the emanations from the lightning strokes. I was thinking that ties into a lot of the amateur radio stuff that we've been doing, and I've got a SDR radio here that I want to see if I can press into service for that kind of thing. So there's so many different things that we could try here. I've got it'll be good motivation too, because I've got a couple of projects, as David says, that have been kind of languishing. So yeah. It'll be good to have a little bit of motivation on that.
Yeah, I think it's great. If you're kind of asked to sort of describe it to people, people will keep asking you, well, how are you doing? So, I mean, it's good motivation to get them finished.
Great.
And yeah, so I think the other SIGs are going to start up again, as we get to the beginning of next month. We'll do the beginner stuff, and we'll have EAA again, and John will have the astrophotography again. So yeah,
I think John's astrophotography, I think, is next week, isn't it? Is that right?
Oh yeah, okay, that's great. Yeah, that's great. So yeah, I'm really looking forward to seeing all these SIGs spin off, and the beginners group kind of progress a little bit more. I'm hoping the beginners group will be kind of like a bit of a potluck kind of sampler thing, because I know the other ones are a little bit more specialized, but the beginners group almost anything's game as far as I'm concerned. Sort of just to introduce people to, different kinds of things about learning about astronomy.
Great. Does anybody else have anything for this evening?
Yeah, I have something I'd like to share, please, if you don't mind.
Yeah, please do.
Okay, here we go. I have two screens, so I have to figure out how to get the right screen up here. Here we go. Okay, this one here. Are you guys seeing, what are you seeing now?
Nothing yet.
Okay.
There it goes. Okay, it started now.
Okay, what are you seeing so far?
Just
There we are. We've got a, what is it, some dial? Oh,
right
it
here?
went to your camera.
a quick capture.
Okay, is it do you see a 2,000-year-old Greek astronomical calculator in front of you?
No,
That
we
was there
did, we
first.
did, we
We
did
did.
see, we did see some kind of Ori kind of thing, but it's
Yeah.
not there anymore.
No, now we're seeing your quick capture webcam.
Okay, here we go. Do you see it? Do you see the orrery thing again?
Yes.
Yes.
Yeah.
Okay, so this is very cool. This is one of the world's first analog computer.
Hmm.
Yes, so this is a calculator built by the Greeks. It's called the Antikythera mechanism, showing the positions of the sun, moon, and 5 planets, as well as the phase of the moon and the nodes of the moon. And get this, it's Earth-centric. So some very clever dudes back then built this thing, and they lost it overboard on a boat trip, and they found it again, and they've been having a heck of a time trying to recreate how this thing was put together. And here is what the Greeks produced 2,000 years ago.
Hmm.
Now, if you're a gearhead like me, this is just amazing. This, by the way, is a digital drawing, but they finally, after decades, figured out how it works. And believe it or not, they even have mechanisms within this thing to have the retrograde motion of the planets as visible from Earth in this calculator. It's hand driven. And so to me, being a gearhead, I just say, wow, that was some pretty darn clever engineering to do this thing here, And here's the different plates of it. And of course, the pieces they found, here's the kind of pieces they found below, little wee bits of it. And then they found, this is the piece, here's more of the mechanism. So think about it. How on earth did the ancient Greeks do this?
I'm just wondering how they were able to machine it.
Exactly, that's what I'm talking about. Like, how were they able to machine it? Like, this is totally
all made by hand, I guess.
All made by hand. And here's the Earth and the moon right there, and all this other kind of stuff.
Wow.
And let me see here. If you can just read here, 2 critical numbers in the X-ray of the front cover, 462 and 442 accurately represent the cycles of Venus and Saturn. And
Well,
it's just like, wow. And here's other pieces they found. And the most important thing, the most amazing thing, this is actually what they found. This plus a bunch of other pieces. So imagine losing this thing overboard all those years ago. Like, that would have been a big oops, like, good grief.
You
Garry,
said
it
this is the first
sounds
one.
like you've got a project. You got to build one of these things and have it in the observatory down there.
No. I'm an electrical engineer. It's up to a mechanical engineer to build.
But this wasn't the first one, Garry, because this is too sophisticated to be the first.
Yeah.
Like, there had to have been more before.
Yeah.
I don't know. This is just anyhow, I thought this was worth sharing. It's all about astronomy here. Here we go. I'm stopping the share.
Like, if somebody found Perseverance, they wouldn't say this is the first Mars lander.
Yeah, you're right. You're right. There must have been. You're right. There must have been other ones.
I have 2 questions. I hope they didn't call it antique. And
I don't know.
and what was it made out of? What metal was it made out of? Or
I'm afraid I forget.
I think it was bronze, Chris.
That's right. It was largely made of bronze.
Yeah.
And is it that easy to handle bronze? I don't know.
Well, I'm just wondering if that gives you a clue to the period of time then, if it's bronze, right?
I know that the ship, it wasn't so much lost overboard as it was a shipwreck off the island.
Shipwreck. It was a shipwreck.
And it was the ship from the other cargo on board. It was bound from the city of Syracuse and I'm not sure where it was going, but it was a fairly regular trade route, and it's possible that it might have been built by Aristotle or some of the students of Aristotle as well. So it's yeah, it's pretty advanced technology, and it would have been advanced for the time, but not totally unprecedented.
Yeah. It's called the Antikythera mechanism. Anti-Kythera mechanism. Pretty amazing, anyhow, I thought.
Probably brought by the same aliens that created the Nazca lines.
Oh, it's the same aliens that brought us the pyramids.
Don't say that to an Egyptian. They'll start asking you, do you think our ancestors were stupid?
It's a good project for a 3D printer.
Yeah, that's what I was thinking. That would be quite.
Get to work, Joe.
Anyways, well, I think this probably we'll call it an evening, unless there's anything else. Just a reminder that next week we're expecting Sky News editor Alendria Brunhes to join us. So if you've got any questions about Sky News, and is this the latest one, I guess?
This is because I'm on the publications committee. I get to look at it. This isn't even in production yet, but it's going to go to the press in about 48 hours, and I get a look at it. So I thought since Alendria is coming next week, I would share this with you. So this is the next issue of Sky News.
So there, you've seen it here first.
That's right.
We're special.
So if you have any questions for her, or comments, I guess, about where Sky News might be going, or, this is the time to ask and hear more.
Is anyone capturing stuff tonight? It's clear out.
Well, Bill Weir has headed off.
Okay.
And the moon has this beautiful 4 craters right along the terminator. It'll be absolutely beautiful. And we have 1 more hour before it sets.
Yeah, it was pretty low when I looked. I was out there setting up earlier and it was disappearing.
I think I may be taking a walk up to the top of Mount Ptolemy to see what I can set up with the camera.
Yeah, so anyways, well, we'll let people get on to that. So thank you for joining us this evening, and hopefully you'll be back next week, and let us know if there's topics you want us to cover as well. We'll see what we can do, or if you want to present.
Great. Thanks, everybody.
Take care, everyone.